Okay, guys. Just FYI, the notes are labeled kind of funky. They don't really line up with what's in Canvas. This is actually 8.3 lesson, not 8.3b. So we'll call that 8.3. Just FYI, that's how it's going to be in Canvas. Okay, so we're moving on to what's called inverse trig. So what we learned already is that if I'm given an angle and a single side, and that's the only information I have, I can actually find a missing side of the triangle, or actually both missing sides of the triangle if I need to. We can actually go in reverse as well. Inverse means to go in reverse. Yeah, to invert something means to flip it. So we can actually find angles as well, and that's what inverse trig is for. So again, you can kind of highlight it here. Inverse trig is to find an angle. Regular trig is to find a side length. Inverse trig goes in reverse and finds the angle. So you're going to see, I'm going to show you the other calculator. I have a little emulator here, so you'll be able to follow along in the calculator. These buttons, sine -1, cosine -1, tangent -1, we read this as inverse sine, inverse cosine, and inverse tangent. So let's go ahead and let's practice this. And we'll start off in example 1 with actually practicing going into the calculator. So what we've done before is that the trig function and the angle are married to each other, right? Sine A, they have to go together. But what if I don't know the angle, right? What ends up happening here is we invert this. Again, invert means to flip or to switch. So I'm going to rewrite this. What happens is the angle and the ratio, typically this is a fraction, but we know 0.5 can be a fraction, right? We know 0.5 is 1/2. They will switch places. This is what it means, again, to invert. So because they're switching places, we say sine -1. This is now called the inverse of sine because I am inverting the angle with the fraction. Now, again, it's a decimal here, but usually we see it as a fraction, yeah? So what happens is they switch places, and all I have to do from here is actually plug this in the calculator to get what the angle is. That's it. Let's go ahead and go to the calculator. You can follow along with me here. So you see the sine, cosine, and tangent buttons, right? We've been using those. Right above in yellow is the inverse functions. So I'm going to go, this is old stuff. Let me clear this. Okay. So again, to access that, it's yellow. I have to hit the yellow button. So I'm going to hit shift first, and then I'm going to hit that, sine. Notice now it's sine -1. I'm going to put my ratio, and, oh gosh, give me one sec here. Let me change these settings. My calculator is in the wrong setting. Your guys' all should be in the right setting. Let's try that one more time. Shift, sine, shift, sine, 0.5. There we go. It should be 30. So what this means is angle A is 30 degrees. Normally, we're given the angle and we can find a side length with it. Now, we're trying to find the angle, so we're going in reverse. So let's try this one again. Again, inverse trig switches the angle with the ratio. These are going to switch places. And to make it inverse trig, we have to tack that -1 on there. So again, 1's going to come over here and A is going to go over here. All you do with inverse trig, this is the nice easy thing about it at least, all you do with inverse trig is go straight to the calculator. That's it. So let's go ahead and come here. I need inverse. You're not going to type the -1 yourself. Don't ever type the -1 yourself. I don't think it will work. So we're going to go shift, hit the inverse, make sure I got that. There we go. Hit the tangent button, and now I have the inverse of tangent. And it's just 1. 45. Okay, so this tells me angle A in this case would be 45. Try it one more time. Go ahead and try the last one by yourself in the calculator. Again, these are going to switch places. That's called invert. So I have cosine -1 equals 0.15. That's going to, sorry, not equals 0.15. Inverse cosine of 0.15 is going to give me my angle. So take a second, plug it in the calculator, and then compare and see what you get. Okay, so I need inverse, so I'm going to hit shift. Oops. Cosine, come on. 0.15, enter. Should have gotten 81.3. We're going to round that to one place. We'll go ahead and go 81.4. Angle A equals 81.4. Okay, so that's how you plug it in the calculator. And the nice thing about inverse trig is that's it. It doesn't get more complicated than that. However, let's go ahead and look at example 2. You still have to label your sides. Now I'm going to kind of cross off a few things here. We're not solving for a side length. We could solve for that side length actually, but the focus right now is just inverse trig. As well as, let's only go ahead and focus on angle A so that we can just do this once at a time. So we're just going to solve for angle A. So what you need to do is mark angle A, because remember, when we label our sides, our perspective changes depending on the angle. So we know how to do this. My goal is to find angle A. That's how I know it's going to be inverse trig. If I'm trying to find an angle, I'm going in reverse. That's inverse trig. So please label the 10 and the 8. What are they? Again, I don't know this side. If you need to label it to know what 10 and 8 should be, you can. But then erase that label. Don't leave it to be confused. Okay, 10 is the opposite. The blank side is the hypotenuse, so I'm not going to label it. That leaves 8 to be the adjacent. And then I write my best friend, SOHCAHTOA. This is still all the same, right? Still always labeling sides. And still picking the right fraction. So we only have the opposite and the adjacent. I've got sine, cosine, tangent, SOHCAHTOA. Which trig function do I have to use? That's going to be tangent, TOA, opposite, and adjacent. But again, it's inverse trig. So I'm going to show this once this way, and then I'll show you how you can go straight there. Normal trig is written this way, right? We've done this before. Normal trig is tangent of my angle. They are married to each other. Equals my fraction. Take a second to write your fraction really quick. It's O over A. What should be the fraction? In this case, my O is 10 and my A is 8. So this is normally how we write trig, right? Trig function angle equals fraction. But inverse trig allows us to solve for an angle, and so these two switch places. But again, causing them to switch places means that I need to call this now reverse land trig, right? Inverse trig. This is going to be tangent -1, 10 over 8, is going to give me my angle. And again, the nice thing about this is you go straight to the calculator. So go ahead and plug it in, plug this into the calculator, and this is going to be the measure of angle A. Okay, let's check. So I've got shift, I've got inverse tangent, and I'm going to go ahead and let me check this really quickly. I'm curious here. Make sure you put this in parentheses, guys. Sorry, if you did not, be careful with the fractions. You might need to put this in parentheses. 8 divided by 10, or 8 fraction 10, right? Okay, you should have gotten 38.6. I'm going to check really quickly here. I'm not sure if you don't put it in parentheses, if it'll still work out. 8 divided by 10. Yeah, be careful. So different ways you could plug this in. I think maybe if you do the fraction, it'll work out. 8. Oh, shoot, 10 over 8. Good Lord, I'm wrong anyways. Let's go delete. Delete. 10 over 8. Good Lord. I have to clear this out. There we go, 51. Okay, so shift, tangent, parentheses, 10 divided by 8. Okay, so yes. So again, backtracking here, I made some mistakes. You can plug it in either of these ways. So you can just hit the fraction button and do 10 over 8. If you're going to do 10 divided by 8, you have to put it in parentheses, otherwise it'll get messed up. So I recommend you use the fraction button. So the measure of angle A is 51.3. And again, this is degrees because we're measuring how big that angle is. So let's go ahead and try it again. Again, let's go ahead and solve for angle L this time. So I'm going to solve for just angle L. Go ahead and label just the 8 and the 9.2, and then we'll go from here. Okay, 8 is my opposite from angle L. If I'm just solving for angle L, 8 is my opposite, and then 9.2 is the hypotenuse. So with our best friend, SOHCAHTOA, please tell me, which trig function do we have to use? Sine, cosine, or tangent? This is going to be sine, right? I have opposite and hypotenuse. That's the O in sine. Now, what you can do if you're doing inverse trig, as I showed you on the last one, typically how we see it is trig function angle equals fraction. We know it's going to end up here. So we can just go straight there. So I'm going to do inverse trig, because again, I'm inverting this. In reverse land, it's like my trig function is now divorced from my angle. And instead, it's getting together with our fraction. So I'm going to go inverse trig, fraction. Again, that's the reverse of what it normally is. That's why it's called inverse. Go ahead and take a second. What's your fraction? We need the opposite over the hypotenuse. What's the fraction? 8 over 9.2. Has to be that way. And again, the nice thing about inverse trig is that I can plug this whole thing in the calculator. So take a second, go to the calculator. We're going to plug that in and get our angle. Okay, I need shift, sine. I'm going to go fraction button, and I'm going to go 8 over 9.2. I'm going to hit enter. Come on. You should have gotten 60.4. And again, this is degrees because we're measuring how big that angle is. So you can skip straight there. I just want to show again that typically this is how we see it. But inverse trig, we are switching places. Yeah. So we're going to try it just one more time. This looks like a really weird picture. X is this angle here. Yeah. So just keep that in mind. That's the angle we want. Label your two sides. Do the whole thing. Label your two sides. Pick your trig function, do your inverse trig, see if you can get all the way to the end to get the angle. I'm just going to talk through it. Okay, your labels should have been 15.7 is opposite. My blank is the hypotenuse, so I'm not going to label it. 59 is the adjacent. That gives me tangent, TOA. Now again, because I'm finding the angle, I'm going to use inverse tangent. And I'm inverting what we normally had. Normally, tangent is married to the angle, but now it's getting together with the fraction. It's reverse land of what we normally have. And then I go straight to the calculator. I need 15.7, so I got shift, tangent, fraction, 15.7 over 59. I'm hitting enter. So my angle here is 14 point, let me double check that, 9. Yep. 14.9 degrees. There we go. So again, guys, inverse trig is actually easier because there's no cross multiplying. There's no having to solve. Literally, if you can recognize you need to find the angle, it's all calculator work. So you're doing this 4 more times in your assignment. Again, it's just boom, 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 plug in the calculator, label your sides still, all that jazz.